Hello friends, so how are you doing? And I hope you really are having a great and fun time. This is Dr. Ashmeer with you, and we will discuss the CBSE 2018 sample paper for class 10 science paper. As you know, the science paper consists of biology, physics and chemistry. It's a combined paper which gives question of all these three subjects. So this paper, which is consisting of all the questions of these subjects, will be discussed by the respective trained faculties of each physics, chemistry as well as biology. I'm going to discuss with you all the biology questions, and the other faculties will discuss their respective questions in detail. So friends, we are going to do this in detail. Okay, you need to understand this, what you have to write. You have to pick the right things and then write those things, but we are going to explain you the logic behind it, the whole rationale behind the question, and why, what you should know in a particular question and how to frame your answer. Okay, so let us start this 2018 sample paper, and the first question for you today is: the diagram below shows the structure of a neuron. A beautiful diagram. They generally don't give such beautiful diagram in the books, and that is why many of the books become monotonous. But gradually they have started giving colorful diagrams. So state the function of the structure labeled as X. Right, this is X. In fact, this whole thing can be X. Okay, so what will this be? You all know that this is the structure of a neuron. Okay, I'll write it here. The whole thing, is it written? Yes, the whole diagram. So no need to write this. The whole diagram is the structure of a neuron. Right, a neuron. Let us discuss the body parts of a neuron. The body parts of a neuron consist of the cell body, as I have mentioned over here. The cell body, that is the soma, the nucleus. There may be certain granules over here which are called as the Nissl granules. Okay, the Nissl granules. This is the part which we are concerned about. This is the part which is called the axon. Okay, and these are what? These are the dendrites. These are the dendrites, and here this will form the motor end plate. Right? So in certain cases we will see what is the basic function of a neuron. The basic function of a neuron is the transmission of nerve impulse, conduction of nerve impulse. So the basic function of this structure, which is the axon, is again the conduction of the nerve impulse. What happens when the impulse, for example, if you prick a finger, if you if something, some thorn pricks your finger, okay, over here, what happens? The sensations from the receptors of this finger comes through the neurons to your central nervous system, that is the brain. Okay, and the central nervous system consists of the brain and the spinal cord. Okay, so from here the sensations from the finger, from the receptors of the finger, comes all throughout and comes to your brain, and then your brain perceives it as a prick, because your brain doesn't know whether it is a prick, whether it is a good thing or bad thing. So your brain perceives it as a prick, and immediately through the motor nerve fibers it will send the signal to the muscles over here to contract, that is, remove your finger. And this all happens in some microseconds or fraction of a second. Right? So how is the message going from this part to the brain? It is going through the neurons, and hence the conduction of impulses is the function of the neuron, and in particularly the axon. So labeled as X. The structure labeled as X will be what? Axon. Okay, the structure labeled as X will be the axon. This is the axon. And what is the function of the axon? The function of the axon the function of axon is conduction. The function of axon is conduction of nerve impulse. Okay. The function of axon is conduction of nerve impulse, that is, this axon is conducting the nerve impulses further to one neuron to other, from the second neuron to the third neuron, and finally it will either reach the brain, that is the central nervous system, or these ends will combine with that of the motor muscle, that is the muscles at the motor end plate, and hence will give the right communication or the right message to the muscles. Okay. Now we will see that in some cases these axons, there is the presence of myelin sheath. Okay, there is a presence of myelin sheath, like I am drawing it here like somewhat like this, and these are nodes of Ranvier. Okay, this is not I am just telling it, you need not write this over here. So what happens when the nerve impulses are traveling? When the nerve impulses are traveling, the nerve impulse from here will directly come to here, it will directly come to here, it will directly come here, okay, from here to here, that is from one node of Ranvier to the other. Why? Because this axon is covered by a sheath called the myelin sheath. Okay, this is called as the myelin sheath. Okay, myelin sheath, and such a nerve is called as a myelinated nerve fiber. Myelinated nerve fiber. I am changing the pens because it is getting dull after writing one word. Myelinated nerve fiber, right? So when the myelin sheath is present over the axon and that neuron will be called as a myelinated neuron. And what happens in a myelinated neuron? The impulses will travel from one node of Ranvier to the other. Okay, from one node of Ranvier to the other. These points are called the nodes of Ranvier, and hence in the myelinated nerve fiber the impulse will travel at a faster rate because it doesn't have to travel throughout the whole length of the axon. You are getting it? Only these nodes. So the distance is reduced. It jumps from one node of Ranvier to the other, and hence in myelinated nerve fiber the time taken for the impulse conduction is very, very less as compared to the non-myelinated nerve fiber, that is in those where the nerve fiber does not have the myelin sheath. So such a conduction of impulse where the myelin sheath is there, that is in case of myelinated nerve fiber, such a nerve conduction is called as the saltatory conduction. SALTATORY, saltatory conduction. Okay, and I'll explain you why this saltatory conduction is needed. I'm telling you and repeating again that this is not needed, but just to explain you, since we were discussing about axon, so I felt like telling it to you. See, what is the need of myelin sheath? Now what will happen, say there is a neuron, okay, there is a neuron. Now what happens, all the cyton, all the cell body, soma will be together and all the axon will be together like a bundle of sticks. Okay, in a body there will be many neurons. So all the axon will be together, this axon and maybe this axon. So it will be like this. It will be like this, and the cell bodies of these are here. So what happens when the nerve impulse are traveling, these may get mixed with each other. So to prevent the mixing of the impulses, to provide for the insulation of these nerve fibers, these myelin sheath are there. That is, one impulse did not get mixed with the other. If that happens, what will we know the result? I mean, gross mistake. Suppose you are pricking a finger and that message goes to some other part of the brain and that will say, okay, prick more, and you will hurt your finger. Maybe you can even cut your finger. So the right thing has to go to the right nerve fiber. So that is why the myelin nerve sheath will be there. It is not there in all the nerve fibers. Where the myelin nerve sheath is there, that axon or neuron is called as the myelinated nerve fiber. That conduction is called saltatory conduction, and that's it. Okay, so this removed this. Okay, so done. So let us just, so the diagram shows below the structure of a neuron. This part is the axon, and the function of the axon is conduction of the nerve impulses. That's it, you have to write. No need to mention about the saltatory conduction and all that. That was just a little something extra. So we will move on to the next question. Study the given equation carefully. Yes, milk, lipase 30-minute, x plus y, okay, the x plus y and acidic milk. Okay, the identify the substrate on which lipase acts and also x and y. Now lipase. See, there is a rule for an enzyme, that all the enzyme should end with ase, and also the initial letter should be part of the substrate on which they are acting. So lipase is an enzyme ending with ase, and LIP means lipid. For example, proteinases. Okay, ase, that means enzyme, and protein, that means they will be acting on the proteins, right? I mean, most of them, there are some, there are many examples which does not follow this rule, not necessary. Okay, so lipases, carboxypeptidases, which will act on carboxypeptides, okay, peptidases which will act on peptides, and so on. There are many examples. In this case, lipase are a group of enzyme, okay, lipase are a group of enzymes, okay, lipase are a group of enzymes which act on lipids. Which acts on lipids, okay, lipids. Now we will see lipids are basically what? Lipids are basically the fat, right? Lipids are basically the fat, and when we break down the fat, these you will get mainly the glycerol plus fatty acid. So the word lipase means that yes, it is acting on the lipid, and then to act on the lipid, definitely there has to be lipid in the milk, right? So identify the substrate on which lipase acts. Lipase are a group of enzymes which act on lipids, hence this is not dark, hence the substrate, okay, hence the substrate in milk, hence the substrate in milk on which lipid acts, on which lipase acts, on which lipase acts will be lipids, and lipids are what? Lipids are nothing but fats. Okay, we know lipids are nothing but fats, and hence identify, so the substrate on which lipase acts, so these lipases are acting on the substrate lipid in the milk, okay, and after 30 minutes this will be breaking down into what? X plus Y plus acidic milk. So what is X and what is Y? We all know that lipids, when acted upon by lipases, okay, lipases forms fatty acid, fatty acid plus glycerol. Okay. So these lipids, this will act on, these will be acted upon by the lipases and will form a fatty acid and glycerol, and hence definitely X will be what? Fatty acid, and Y will be glycerol. Okay. So X will be fatty acid and Y will be glycerol. So even this completes this answer, that yes, there are lipids present in the milk which will be acted upon by lipases, and this results in the breakdown of lipids and form fatty acid as well as glycerol. Fine. So now students, we will see the next question. When zinc metal is treated with a dilute solution of a strong acid, a gas is evolved which is utilized in the hydrogenation of oil. Okay, this is a question pertaining to chemistry, so the chemistry teacher will be solving it.
So hey guys, now I am here with you, your chemistry teacher, and now I will be solving all the continuous chemistry questions that will be there in the paper. Okay. So the question, I think your teachers have already discussed 2 questions with you. Now we are there on the 3rd question. And the question says, when zinc metal is treated with a dilute solution of strong acid. So we have zinc metal taken in the solid state and you are treating it with a dilute solution, but the dilute solution that you have taken is of a strong acid. Okay. A gas is evolved which is utilized in hydrogenation of oil. You remember which gas is utilized in hydrogenation of oil? You have done in the chapter carbon and its compound. For example, this is ethene. Pass hydrogen gas on the surface of platinum, it will lead to the formation of ethane, right? So we know, right, that hydrogen gas is utilized for the hydrogenation of oils. So I will say hydrogen gas will be released. Okay. So name the gas evolved. Now see, whether or not you know the reaction, I don't know. But you need to know that hydrogen gas is used for the hydrogenation of oil. So this is very clear that which gas is used for the, which gas has been evolved, that is hydrogen gas. Okay. Now the second thing, write the chemical equation of the reaction involved and also tell a test to detect the gas that is formed. That means what he wants us to do, he simply wants us to write down the chemical equation of the reaction taking place, and then you need to tell how the gas could be identified. Okay, let's do this. So you take zinc in the solid state, treat it with, let us say, H2SO4 in the aqueous solution. Okay. Now there will be exchange of the cation anion. So zinc will lose 2 electrons to form ZnSO4 in the aqueous state, plus hydrogen in the gaseous state will be released. Okay. So let's do a total count of atoms: 1 zinc, 1 zinc, 1 SO4, 1 SO4, 2 hydrogens, 2 hydrogens. So always make sure that the equation has to be balanced. Else you could have also written zinc in the solid state will combine with HCl in the aqueous state to form ZnCl2 into the aqueous state plus hydrogen in the gaseous state. So let's try to balance it. 1 zinc, 2 chlorine. So make a total of 2 here, 2 hydrogens, that's it. Okay. So this is the equation that I have written. Now we need to tell a way with the help of which you can detect or you can identify that yes, the gas evolved was hydrogen only. Now let's say you have this system zinc plus HCl, ZnCl2. Now what you do? You cover it. Okay. Now you know, right, that the gas is being released. So try to pass this gas through the U tube and let us say now you need to pass it through the container containing soap solution. So let's say I am having a container and I have taken a soap solution in the container. So this I have taken as soap solution. Okay, now what will happen since the gas bubbles are coming up? So the gas bubbles will be getting into the soap solution. So they will form bigger bubbles, they will rise up, rise up, rise up. Now these bubbles that are formed, now you bring a candle, and as soon as the bubbles, the soap bubbles which are having hydrogen gas, they will come close to the candle, you can say it burns with a pop sound. So whenever there will be a pop sound, then you can say, so the gas will burn out, and that too with a pop sound. So if you can if you can hear the pop sound of burning, then you can say the gas was hydrogen gas. Okay, so this was about our question. Let me see if the next question is of chemistry. No. So the next question is of physics. So that is it for your chemistry question. Let me go, let the physics teacher come in and tell you the next answer, and then I will come back for the chemistry questions. Okay then, bye-bye.
Hello friends, till now we have done 3 questions which was basically from chemistry and biology. Now it's turn to do the first question from the physics session, CBSE 2018 sample paper for class 10. Just look at the question, what is this demanding from us? So let us see the question. It is saying us to draw an IV graph for the following data, and also we have to verify Ohm's law. We have been given with voltage, that means V, and current, that is in ampere. First of all, before starting the question, I would like you all to know about the Ohm's law, because without knowing the Ohm's law, we cannot verify it. So first of all, what is Ohm's law? Since it is a 1-mark question, it just depends on you that you are going to define the Ohm's law first or not. Because we have been said to draw the IV graph and we have to verify it. So it just totally depends on you whether you are going to define Ohm's law first or not. It is not mandatory to define the Ohm's law, but to make you understand, I am just writing it here. So the Ohm's law states that the potential difference across an ideal conductor is directly proportional to the current flowing through it. Is directly proportional to the current flowing through it. Now, if I am saying that this potential difference is directly proportional to the current flowing through the conductor, what does it mean? That means V is proportional to I. And if I am saying that V is proportional to I, then that clearly means V and I will follow a linear relationship when they are going to be plotted on the VI graph. So let us draw the graph and just verify this for the question that has been demanding from us. So if I am going to draw the IV graph, first of all we will be having voltage on x-axis, this is x-axis, and my current would be on y-axis. This is I and this is in ampere, this would be in volt. So let us go back and see what are the values that has been given to us. So here when V is 0, I is 0. So I can just put a dot on 0 and 0 because this is the origin. If now I see the V is 0.4 and I is 0.2. So I am just going to mark first of all 0.4, just mark for the values of V, that is on x-axis. So that is a multiple of 4, 4, 8, 1.2, 1.6, 2, 2.4 and 2.8. We are just going to divide the x-axis according to the condition that has been given. So that would be 1.2, 1.6, 2.0, 2.4 and 2.8. Now if I am going to see for the I-axis, that means y-axis based on the current, that means I have to draw the multiples of 2. 2, 4, 6, 8, 1, 1.2 and 1.4. So that means here it will be 0.2, there 0.4, 0.6, 0.8, 1.2, 1 and 1.2. Alright. So if I am going to plot the values, so just look at this. When V is 0.4, my I is 0.2. So I am just going to put here a dot. Alright. My V when is 0.8, my current would be 0.4. So 0.8 and 0.4. So this will be a dot. When V is 1.2, I is 0.6. So just a dot here. When V is 1.6, my I is 0.8. So again, just put a dot before the corresponding values. So this is the point. When V is 2, I is 1.0. So again a corresponding point according to x and y axis. When V is 2.4, my I is 1.2. So this will be the corresponding point. And similarly for 2.8, my y-axis was 1.4. So I am just going to write 1.4 over here and I am just going to plot the value of again this point as here. Now we have plotted the points that has been given in the question. If I am going to join these points, what I will see is that they all are lying in one straight line. Might be it is because of my mistake that it is not coming in straight line. But yes, if you are going to draw it by scale, then you will find that they are coming in a straight line. That means they are following a linear relation. Again, from this VI graph, we can say that V is proportional to I, and we know that when V is proportional to I, hence we can say that Ohm's law has been verified. Ohm's law is verified. So this was the question that has been asked to us. We just have to draw this IV graph, we just have to show this linear relation, and we have to say that hence we have verified the Ohm's law. This was the question that has been given to us and that has been demanding to us. Now we will move to the next question. Till then, I want you all to take a note of this.
Okay, so now we'll discuss the fifth question, which is again a bio. Food does not pass through the digestive system by gravity. Yes. Why? Because for gravity it has to pass from up to down. You will say that the alimentary canal is from the mouth to the anus. That it can pass through gravity, but what, if when you are lying down, when you are sitting, when a part of this, lower alimentary canal is, parallel to the ground, or when you are lying down, we lie down almost, 8 to 10 hours a day, and many people 15 hours a day like me. Okay, this is clear. You can get to know from my health. This is clear from the fact that we can digest the food even if we are lying down. Yes, explain the logic behind the passage of food through our digestive system. This question basically wants to know, or this question wants to the answer that what is the mechanism of the movement of food throughout the alimentary canal. So my dear friends, we all know that the alimentary canal, okay, the alimentary canal extends, okay, the alimentary canal extends from what? The alimentary canal extends from mouth to the anus, right? The alimentary canal extends from the mouth to the anus, that is, mouth is the anterior opening of the alimentary canal and anus is the posterior opening of the alimentary canal. If I draw the alimentary canal, which is almost like a tube, this part from which I am speaking, from which I will eat the food, is the anterior opening, is the front opening, which is the mouth, and this part is the anus, which opens outside by the anal sphincter. That is a different thing which we will do later on in the higher classes. So this tube is the alimentary canal. This tube is the alimentary canal. When we are eating something, or when we have eaten something, say you ordered a pizza burger from Domino's and you ate that pizza. So all the cheese, all the, if you're eating cheese burst, okay, all the cheese went inside your stomach. And after the stomach, it will enter your esophagus, that is the throat region, esophagus, then it will enter the stomach. From the stomach, it will enter the small intestine, from the small intestine, the large intestine, and finally, the undigested food will come out through the anus. So it is completing that food which you have eaten when it is moving through the complete alimentary canal. Okay, this whole thing is complete alimentary canal. And when it is passing through the alimentary canal, what are the structures through which the food is passing? The food is passing through the mouth, then esophagus, okay, and after the esophagus, the stomach, and after the stomach, the small intestine, okay, the small intestine, and after the small intestine, it is passing through the large intestine. Okay, this is the whole part of the alimentary canal. Got it? So when the food is passing through the mouth does what? We will chew. We will chew and break down those complex particles into smaller particles. Esophagus, it comes down. In the stomach, the gastric acid, which is a highly acidic acid, is added, HCl. Okay, then it comes into the small intestine where the part of the food is absorbed by the circulation so that it can be utilized, okay, to provide energy, okay, and the part which is undigested will further move into the large intestine where it will be given out in the form of fecal matter. That's it. So this movement of food from the mouth to the anus or to the large intestine needs a force. It needs a force for the movement. There is no battery inside, or there is no key inside that will turn on the key and the food will start moving. That movement of food, that pressure for the movement of food is provided by a movement called the peristaltic movement. Peristaltic movement, or peristalsis we call as, is the alternate contraction and relaxation of the smooth muscles of the alimentary canal, which will propel the food further. Okay, how come we will see that? So, explain the logic behind the passage of food through our digestive system. So, you will not write that part which I have written, that is just to explain you. I will tell you when to write what is appropriate. Okay. So, I will write this as the movement of food through the alimentary canal that is from mouth to esophagus, sorry, that is from mouth to anus, that is from mouth to anus. The movement of food through the alimentary canal, that is from mouth to anus, is due to peristaltic movements of the alimentary canal. Okay, peristaltic movements of alimentary canal. Okay, very, very important this word. So, the movement of food through the alimentary canal, that is from mouth to anus, is due to the peristaltic movements of the alimentary canal. And what is peristaltic movement? Peristaltic movements are alternate. Okay, I've written this obliquely. Peristaltic movements are alternate. Contraction are alternate. Contraction and relaxation. Okay, alternate contraction and relaxation of the smooth muscles of alimentary canal in a wave-like fashion, which will propel the food forward, Okay. So, the peristaltic movements are alternate contraction and relaxation of the smooth muscles of the alimentary canal in a wave-like fashion, okay, which will propel the food forward. This is E, propel the food forward. You can note this down and you can write this part as your answer. Okay, we will just see what it is all about. Okay, I'll explain you in a diagrammatic way, very easy. I explained you that this is the alimentary canal extending from the mouth to the anus. This is just a, an arbitrary diagram. We know alimentary canal is in the form of a tube-like passage. So, when the food comes in, what happens? The food turns into a bolus. The teeth chew the food. The food gets broken down into smaller particles, get mixed with saliva. This saliva, this mixture now forms in the form of a ball called the food bolus. The food bolus is being, put swallowed by the tongue pressing against the hard palate. So, this creates a negative pressure. The food bolus comes down into the esophagus. Now, the food bolus is coming down and say it has come here. Now what will happen? This esophagus part, it will contract like this, wave-like form, contraction, relaxation, contraction, relaxation, contraction, relaxation. Okay, again it will reach the where? After esophagus comes the stomach. So again contraction, relaxation, contraction. The wall of these are contracting, relaxing, and when it is contracting, it is pushing the, as a result of these contraction and relaxation, the food bolus is getting moved forward in the alimentary canal. Okay. So friends, I hope you understood this question, and we will move on with the next question and see the next one. An electric iron has a rating of 750 watt. Okay, this is a physics question, so the respective faculty will solve it for you.
So now we are having our second question. An electric iron has a rating of 750 watt, 200 volt, and we have to calculate the current required, the resistance of its heating element, and the energy consumed by the iron in 2 hours. This is a 3-mark questions, and we have been given 3 points. So this is comprising of 1 each. We can say this is a 1 mark, 1 mark, 1 mark. Okay. Now firstly we have to calculate the current required. Since we have studied the chapter and we know the formula easily, if we know the formula, we can do it very easily because this is a formula based question only. So now we are going to apply the formula that we have to, what we have been given? We have been given P, power 750 watt, and we have been given V, voltage, that is 200 volt. What we have to find is current, I. Guys, are you able to remind the formula which will be related to P, V and I? Yes, yes, yes. This is nothing but P equals to VI. Okay, this is the formula and we have to put the value in this. V is 200 and I is 750. What we have to find is, sorry, I is not. So I will be P by V. What is P? 750. And what is V? This is 200. So if we are going to solve this, we will be having 3.75 ampere because it is a current, so its unit will be 3.75. So we are done with our first part. So if we are going to attempt this in a very good manner, then no one can stop us scoring 1 marks in this question. Then we will move to our second part. Can I rub this? Okay. Our second part is the resistance of its heating element. That means we have to find R. And we have been given P and V, voltage. Again we know the formula P equals to V square by R. And we have to find R. So we can take this R up to the left side and we will be having V square upon P. Since P equal to, so R equals to V square by P. Nothing but we have to put the value of V, that is 200 square by P. Power of V is 750. And this is nothing but 4 into 10 raised to power 4 by 750. Okay, so you can solve it easily and we will be having the value of this as 53.3 what ohm, because unit of resistance is ohm. So we can write it as R equals to 53.3 ohm. This is a very easy question if you are going to attempt this, because this is a very scoring one. If you know the formula, you can correct it very easily. If you know the formula, you just have to put the values and you will gain the answer, and along with that you will gain a good marks. Okay. Now the third part. C part. Energy consumed. Energy consumed by the iron in 2 hours. Time has been given 2 hours. Now friends, since we have been given the time in hour and we know that we are using all the standard units of the dimensions, then we have to convert this into second. 2 hour means 60 minutes into 60 seconds. Okay. Now we have to find energy, and also we know the formula of energy, that is energy is nothing but heat generated, because heat is also a form of energy. So we are having formula H equal to I square R by T. I square RT. H equals to I square RT, where I is, we have found it in the very first part, the current required, and the answer was I think 3.75 ampere. So here 3.75 square into R. R was, we have found R in the second part. See, all the parts are linked to one another, since we have found the current in first part, resistance in second part, and in third part we have to put the value of both the answers that we have been found on 1 and 2. So R here is 4 into 10 raised to power 4 by 750 that we have found in first one, and T is 2 hours, 2 into 60 into 60, or we can write it as 7200. After solving this, we will be having our answer, that will be 54 into 10 raised to power 5 joules. I think this one is correct answer, and the unit will be in joule because unit of energy is joule. So please don't forget to write the unit after the dimensions that you have got. If you haven't write the unit after the correct answer, then you will be having 0 marks in that, and you cannot question the examiner that I was having correct answer but you haven't given me the marks. He won't give you the marks until and unless you will use this unit joule, and this is second, and this is ohm, and the ampere. Until and unless you write the unit along with these terms, you will not be having a marks over the question. So please note it down, and then we'll move further on the next question. Okay. So now our question is, what is meant by magnetic field lines? List 4 properties of magnetic field lines and trace the magnetic field lines around and inside a bar magnet. Okay. So now this is again of 3-mark question, a 3-mark question, and what you friends are thinking that these 3 marks will be composed of, first the magnetic field lines, we have to define this magnetic field lines, and then we have to give the 4 properties of magnetic field lines. So first 1 mark will be of magnetic field lines defining, and the other 2 marks will be of 4 properties that we have to write, and also trace the magnetic field lines around and inside the bar magnet. Okay, I'm sorry, I think it is of 5 marks because there are so many things that the examiner has been asking. So I think this is of 5 marks. What is magnetic field lines? So first of all, what is magnetic field? Magnetic field is the area around a magnet inside which a force, if a particle is coming inside which, it will experience a force. So magnetic field is an area around a magnet where which we can experience the force, we can experience its effect. You can say magnetic field is an area around a magnet in which its force can be, its effect can be experienced. After explaining this magnetic field, we can say that what is magnetic field lines? Magnetic field lines are the lines that fill this area, this magnetic field, with the lines which determines the direction and strength of magnetic field. These are the lines Okay, I can write it down for you. Magnetic field lines are the lines which fill this field. If I am saying this field, then that means magnetic field, which fill the field and determines the direction and strength of magnetic field and strength of magnetic field. If you are going to write this, you will be having full marks, because firstly you have described what is magnetic field and then you are saying what is magnetic field lines. Now we have to write the 4 properties of magnetic field lines. So I am going to tell you I can tell you orally also. The 4 properties of magnetic field lines are that they are, firstly, they are closed continuous curves. Like in this manner they are having closed continuous curves. If this is a bar magnet, you must have seen this. So we can say this is a closed continuous curve. And second thing, if this is a north pole and this is south pole, magnetic field lines originate from north pole and end at the south pole. It comes from the north pole and comes into the south pole. Okay, so this arrow is very important that you have to show, because it is showing that it is coming from here and entering into this side. While inside the magnet, if I say the magnetic field line direction is from south pole to north pole. If I say around a magnet, then that means the magnetic field line is from north pole to south pole. Whereas inside the magnet, the direction will be south pole to north pole. This will be the second property. And the third property will be that magnetic field intensity will be higher, density will be higher at the poles. Okay. The third property is the density of magnetic field will be higher at poles. This is, you can see here. And fourth one will be that these magnetic field lines can never intersect with each other. They are continuous curve, and so they can never be intersected with each other. These are the 4 properties of the magnetic field that you can write. Okay. And the third part is trace the magnetic field lines inside and around a bar magnet. I am going to draw this diagram clearly before you, because this has been asked in the question. Consider this is a bar magnet and this is a north pole, this is a south pole. So we have to trace the magnetic field lines, and I have told you the property is that a magnetic field line is originating from the north pole and coming to south pole. And inside a magnet, if I talk about inside a magnet, then it is coming from south pole to north pole. Okay. So this is the diagram of magnetic field lines inside and around a bar magnet. If you haven't shown this magnetic field line inside the magnet, then also you will not get full marks, because it is been asked in the question that you have to draw inside the bar magnet also. Because I have seen many children who draws only the bar magnetic lines outside the bar magnet, but they forgot to draw the line inside the bar magnet. So this is compulsion and this is necessary if it has been asked in the question that you have to draw the line inside also. So please note it down, note this figure, and then we'll move to the further question.
Okay guys, so once again I am back, and now we will be solving question number 7 we have already done, right? Okay. Yes, so now we'll be solving question number 8 since it's a chemistry question. So let me just read out the question for you. The question says that on adding a drop of barium chloride solution. Okay, what is barium chloride? You know, right? Barium is 2 plus, Cl is minus 1. So the formula of barium chloride is BaCl2. Okay. Since you are taking a drop, that means it would have been an aqueous solution. So on adding a drop of barium chloride solution to an aqueous solution of sodium sulfite. First of all, I'll tell you something. What is sulfate? This is SO4 2 minus. What is sulfite? It is SO3 2 minus. And what is sulfide? This is S2 minus. So since you are adding sodium sulfite, I will say Na2SO3. A white precipitate is formed. So what should be the white precipitate? See, it's a kind of double displacement reaction. The cation Ba2 plus will go to the anion SO3 2 minus. The cation Na plus will come to the anion Cl minus. So this will lead to the formation of 2 NaCl in the aqueous state plus BaSO3. This is white precipitate. Okay. Now let me read the question once again. So the question says that on adding a drop of barium chloride solution to an aqueous solution of sodium sulfite, white precipitate is obtained. Write a balanced chemical equation of the reaction involved. BaCl2 plus 2 Na2SO3 to form 2 NaCl plus BaSO3. That's it. Now second question, it says what other name can be given to this precipitation reaction? See, this reaction is a precipitation reaction because white precipitates are being obtained. But what is the another name? The another name will be a double displacement reaction. Okay, so because the cation will be displacing the anion and vice versa in both the cases, so it is double displacement reaction. Now third point, it says that on adding dilute hydrochloric acid to the reaction mixture. So when you are adding the dilute hydrochloric acid HCl to the reaction mixture, white precipitate will disappear. So you need to explain why the white precipitates actually disappear when aqueous solution of HCl will be added to the given mixture, right? So now we need to start with this particular question also. So I need to prepare the board. So listen to me very carefully. When I am saying you had an aqueous solution of barium sulfite, BaSO3 aqueous. Now you are adding HCl in the aqueous solution, right? So the displacement will take place. It will lead to the formation of barium chloride plus water plus SO2 in the gaseous state. Okay, so now let us see. One barium is there, one barium is there, two chlorines are there, yes, two chlorines are there, two hydrogens are there, two hydrogens are there, three oxygens, one sulfur, three oxygens, one sulfur. So this is how the reaction of barium sulfite with HCl will take place to form barium chloride, water and SO2. Okay. Now this BaSO3, this was although in aqueous solution, but this was white precipitate. And this white precipitate will react with HCl, leading to the formation of completely soluble aqueous solution of BaCl2, because BaCl2 is not white precipitate, I mean it's not precipitate at all, rather BaSO3 is a precipitate. Okay. So this was all about the question. I think now the question is pretty much clear. So that's it. Now let me see if there is another question. Oh yeah, this is also of chemistry, and the question is, how could the modern periodic table remove various anomalies of Mendeleev's periodic table? Okay, like here in the question you have to say how modern periodic table is much useful compared to Mendeleev's periodic table, right? So there were certain problems, there were certain demerits of the Mendeleev's periodic table because of which Mendeleev's periodic table was rejected, right? And now we need to see how modern periodic table could be you know, a kind of, it's giving an edge to the earlier problems that we had, right? So the first thing was the position of isotopes. You remember in the case of Mendeleev's periodic table, we could not place, we could not give different places to different isotopes. Why? Because we said that isotopes are the atoms having the, like, we could not give. See, for example, hydrogen was 1, 1, deuterium was 1, 2, tritium was 1, 3. Okay. So according to Mendeleev's periodic table, if these 3 isotopes of hydrogen were to be placed, then we need 3 different positions. But there were no 3 different positions allocated to hydrogen, right? There was only 1 position given to hydrogen. So there was this problem because isotopes are the atoms of the element having same atomic number but different atomic masses. Okay. But see how the position of isotopes was resolved in the modern periodic table. Modern periodic table has got all the elements arranged in the order of increasing atomic number. But all these isotopes, protium, deuterium, tritium, they are having the same atomic numbers, right? So there is no point of any confusion for the position of isotopes in the case of modern periodic table. Clear? So this was the first thing that was taken care of in the modern periodic table, which was not a good thing in Mendeleev's periodic table, right? Then secondly, moving on to the next thing, which is the position of hydrogen. So see, when we were talking about Mendeleev's periodic table, we could not exactly position hydrogen because hydrogen was showing some properties similar to group number 1 elements and some properties were similar to group number 17 elements. Like some properties were similar to alkali metals, some properties were similar to alkaline earth metals. But when we came on to modern periodic table, we simply fixed the position of hydrogen little separately also and along with group number 1 also. But we always study the main details of hydrogen separately only, right? Because the properties of hydrogen are very similar to the alkali metals and sometimes they are similar to halogens also. But because the outermost electronic configuration, so see, 1/3 good point was the physical and chemical properties. So see, in the modern periodic table, the position of elements was according to their valency. The valency was same, right? So all the elements having the same valency were placed in group number 1. All elements with another valency were placed in separate group. So since the valency was an important thing and we know that the outermost valency or the outermost electronic configuration of hydrogen is same as that of alkali metal, so we were more confident in placing hydrogen with the alkali metals and not anywhere randomly. Okay. The third thing was physical and chemical properties. When you were talking about the modern periodic table, it really became easy for us to predict the physical and chemical properties because we know physical and chemical properties are the periodic functions of their atomic number. They do get repeated after certain intervals, right? And the fourth point was, let us say, the number of atoms, or you can consider the fifth point as, let's say, so you remember when we talk about number of atoms. So the problem in the Mendeleev's periodic table was if someone is having atomic number 58 and the next element I got was 63. So now I am confused how many elements can I keep in between. Like if unknown atoms were there and if new discovery was to be done, then I was confused how many atoms could I place in between them. But with modern periodic table, this thing was very much clear that after 58 it has to be 59, 60, 61, 62. So 4 elements have to be there in between without any further confusion because this was arranged according to increasing atomic number. So all the problems that were faced, like many of the problems that were faced when we were dealing with Mendeleev's periodic table could be easily tackled when we finally started doing the modern periodic table. Okay, so this was our 9th question, which was again very easy. Now, having done with the 9th question, let me see if there is another question that is to be done. Yes, again this question number 10th is of chemistry. It says that when the pH of mouth is 5.5 or lower, it initiates the tooth decaying process. How? You need to give reason. And this is well obvious, right? So see, whenever you will be eating food which contains sugar particles and carbohydrates, fats, like everything is there. So the organic product is there. Right? So when you eat food which contains sugar and other organic products, so some of these sugar and organic products will get stuck in the teeth or stuck in the mouth. Right? So when I am saying some organic particles, some food particles will get stuck in our mouth. Now you know, right, bacteria are there in our mouth. Now what will happen? The bacteria will start decaying the food particles which are stuck there in your mouth. So bacteria will do the decay of food particles. So when the bacteria will do the decay of food particles, it will lead to the release of some acidic substances. So some acid will be released, okay. And if the bacteria will continuously keep on decaying, lots of acid will be released in mouth, because of which the pH of mouth falls below 5.5. Now see, 5.5 is not like 5.5 is actually a bad thing, right? Because when the pH of mouth will fall below 5.5 or up to 5.5, then the solution is acidic enough that it will start reacting with the component of teeth. You know, right? Teeth is made up of calcium phosphate, which is the hardest substance known. It has some composition of calcium carbonate. So this is one of the reason that since calcium phosphate, calcium carbonate, they are basic in nature, so they'll quickly start reacting with the acidic solution which is pertaining in your mouth, and because of which the tooth decaying process will be initiated. And once it gets initiated, then the tooth decay will keep on happening, and at a later stage you will get a hole in your teeth because your teeth will be destroyed, right? So this is the reason in a flow chart. Like, I didn't write the complete sentence, but in a kind of flow chart I have told you how exactly or what exactly happens when the pH of the mouth is 5.5 or lower, how the tooth decay process is occurring. So the reason and all I have given you. Okay. So I think now you must be satisfied with this particular explanation. Let me just see what is the next question that has been asked to you people. I'm sure the next question will not be of chemistry, but still to be, yeah. So there is some electric bell. So your physics teacher is gonna teach you this question. Bye-bye.